so 4.8. In the name of the holidays, the Halloween edition. Okay, so we have part A. Part A was just, you have your absorber, which is your lungs. You have your blood going in, your blood leaving, and the air going in and the air leaving your lungs. So we're labeling the plot. So where would the air in be? Joel?
Well, the air in would have a higher concentration of O2 since your lungs are going to, since the blood's going to absorb some of it, so it would be the higher point because that will have a higher molecular.
Okay. And then the air out is the other point. How about the blood in? Sharon? I saw you raise your hand.
The blood in would be, it would be lower in the blood going in, so.
Okay.
Yeah.
All right, so then we have the blood in and the blood out. So part B, you're hyperventilating. You see a vampire, you're running away. You're panicking, panic attack. What's going to happen? All right, so what is the slope of this line? Who can tell me what the slope of the line is? Shane?
Isn't it negative flow rate of blood over flow rate?
All right, so L over V, right? The flow rate of blood over the flow rate of air going through your lungs. So if you're hyperventilating, your vapor rate doubles. So what's going to happen to the slope? So your slope line is half. So then what happens? The air out, there's more O2 in it, but the O2 in your blood increases. So does anyone, I saw a lot of people when you were doing your problem, the exercise, just arbitrarily draw the slope of the line. And it looked like it was half. Do you think that's going to fly in the exam? No. So problems like this will appear on the exam. So you do want to be accurate when you're doing graphical analysis. So if you know the slope of the line is decreased by 2, it doesn't mean the blood out just doubles and you draw it there. You're not decreasing the slope. I saw a lot of people just do that. That's a common error. If you want the slope of the new line to decrease by half, you have to increase the run by 2. So the run's going to increase by 2, which puts your equilibrium point not quite at half, at double the oxygen in the blood. Any questions about that? I think a lot of people understood it once that became clear. So part C, no vampires. Now you're an alien, you're on in a foreign atmosphere, and there's half the oxygen in air. What's going to happen? Anyone tell me? Where's this point going to go? Yep.
It's halfway between from 0 to that point.
Exactly. So your new air ends here. So then what happens to the slope of the line? To L over V.
It's going to be like around a fourth of what it used to be.
Okay. So if the oxygen in the air decreases, that stays the same, what happens to your rise? Can anyone tell me what happens to the rise?
Your flow rate of the rise of vapor is going to be half.
Okay. So then the slope of the line is going to decrease by how much?
I was going to say your run's the same, but your rise is above the one that we used to do.
Okay. Yeah. So the slope's going to decrease by about a third or fourth. All right. Part D. Now you get caught by the vampire. The vampire in part A, you run away, it caught you. It sucked out half your blood, but he didn't kill you. He wants to keep you alive so he can take your blood later. So he inserts a saline solution, and now your blood has decreases its ability to absorb oxygen. So what happens when you lose half your blood, and now you have salt water running through your veins? What do you think is going to happen next? What happens to the plot?
Does the equilibrium line change?
Yes, the equilibrium line is going to change. In which direction?
It's going to move down because you're going to be absorbing less blood or less oxygen.
It's going to move down?
No.
So if the equilibrium line moves down, you're really shifting to the right?
Yes,
Which
you're
means at every
increasing
point.
your mole fraction, so it's going to be up.
Okay, so it's really an increase. It's going to go up or shift to the left.
Yeah.
So the equilibrium line for diluted blood, Jack's right, it's going to shift to the left because you can't absorb as much oxygen. So then again, now you have a new equilibrium point. You want your blood out to be the same. Air in is the same, blood in is the same, but your equilibrium line shifts. So now the only thing that's really changing is the air out is going to have more oxygen in it.
What about the breathing rate?
Anyone tell me about the breathing rate? Check.
It's gonna increase.
Okay. It's going to increase? Okay, the breathing rate increases. And what's going to happen to the slope of the line? Decreases again.
But how much faster do you have to breathe to maintain the same blood out?
Much faster.
Much? Anything quantitative?
Yeah, any quantitative estimates, guys?
Yeah, fun line. So just as some people got penalized for having too many significant figures or insignificant figures, much is too little significant figures. You want at least one or two significant.
All right, so again, you just look at the rise over the run. So right now, the rise is decreasing by how much? What was you guys estimating? So you know the run's the same, but your rise is decreasing by maybe a sixth or a fifth. So then your breathing rate's going to increase by a sixth or a fifth. All right, so part E.
Wait,
Yep.
on the last part, the equilibrium line, is that halfway between where the axis and
Yes.
So
yes?
yeah, it is halfway.
So if you got picked up by the EMS, what would they do? Just try to breathe faster till we get to the hospital?
No, you have to breathe a higher concentration.
Like how high?
Like 6 times higher.
Maybe 100% higher. So instead of starting at 21% of the vapor being air, 100%. You breathe less. Still be fine.
All right. Part E. Now we're looking at CO2 in the blood instead of oxygen. So where's CO2 coming in going to be? 0. They estimate at the beginning that air in has around 0% mole fraction CO2. The same blood and the same airflow rate as in part A. So you're going to have the same L over V. So the new points are just going to look like this. So you have your blood out, your air in. So the mole fraction of CO2 is decreasing, and the mole fraction of CO2 is increasing in the air, but L over V is still the same. Any questions about the CO2?